Big Blossom Greenhouse was commissioned to develop an extra large rose for the Rose Bowl parade. A random sample of blossoms from hybrid A bushes yielded the following diameters in inches for mature peak blossoms. So these were the diameters of the roses. Okay. Use the defining formula to find the sample variance and standard deviation. So here is your defining formula, right? Variance, that's the variance, and that's the standard deviation. So let's keep that handy and let's see how to calculate these guys, right? Now, here. So several steps involved. So you need x minus x bar squared. Add them all up over n minus 1. So let's go. So that's your x. That's x minus x bar. So first x bar. Let's figure that one out. N is 6. What is x bar? What is the mean? You are going to add all the x's, divide by 6, right? How did I get n equals 6? Look at that. 1, 2, 3, 4, 5, 6. There are 6 numbers. So first add these diameters and divide by 6. So when you add them all out, you get 36. 36 divided by 6 is 6. So the mean is 6. Take x, subtract 6. Okay, and 2 minus 6, negative 4, 3 minus 6, negative 3, and so on. For each value of x, you are subtracting. And then, if you actually simply add them, you will get 0, so that's no good. Square each. Okay, negative 4 becomes 16, so make sure everybody here is positive, then add them down. All right, okay. Once you have added, you are going to divide by n minus 1. 6 minus 1, 5. So for variance, you have added all the squares of the differences. You are going to divide by 6 minus 1. That's a 5. So that is your variance. Sample standard deviation is simply square root of the variance. Okay, approximately 3.74. So notice you are going to use calculators most of the times. Okay. In most application of statistics, we work with a random sample of data rather than the entire population. What happens? So notice all of the formula we looked at had n minus 1 because we are looking at sample. What happens if you have population? Population mean is denoted by mu. What is that? You add all the x's, divide by n. Variance, here you see it is capital N. It is not n minus 1 as for a sample. For a sample, you have n minus 1. For a population, you simply have the n. That's the only difference. That's your variance, and standard deviation is square root of the variance. All right. Note, formula for mu, that is the mean, is same as the formula for x bar. Okay, there should be a bar here. That bar has moved there, x bar. And that the formulas for variance and deviation, this is variance and this is deviation, are the same as those for s squared and s, except that the population size is capital N instead of little n minus 1. Okay, that's the only difference. Mu is used instead of x bar in the formulas. In the formulas for S and sigma, we use n minus 1 for S and capital N for sigma. The reason is that capital N represents population size, small n represents sample size. Since a random sample usually will not contain extreme data values, we divide by n minus 1 so as to make s a little larger than it would have been had we divided by n. Okay, so we divide by something smaller to make our standard deviation a little larger. Courses in advanced theoretical statistics show that this procedure will give us the best possible estimate for the standard deviation. In fact, S is called the unbiased estimate for sigma. If we have the population of all data values, then extreme data values are present. So we divide by capital N. Okay. So S is called the unbiased estimate for sigma. Okay. Whereas the computation formula for sigma is, look, it's quite similar to this, except instead of n minus 1, you have a capital N. Okay. Now look at immediate applications of standard deviation. The first is, and this should be moved up. Okay. So let's look up coefficient of variation and Chebyshev's theorems. We'll look at them in our next video. So coefficient of variation will come up next. Until then, bye.